Cool, awesome. Sam, you can hear me okay, right?
Yeah, I can hear you just fine.
Okay, let me just do the quick introduction. So good afternoon, everyone. Thanks for joining through Zoom for the Stanford Blockchain Club Fireside Chat. My name is Lingji. I'm an Honor Cooperative Program student from Computer Science Department at Stanford University. Meanwhile, I work at a centralized web service provider company called Amazon Web Service at this moment. It's my great pleasure to introduce Sam, CTO of Mysten Labs. Sam used to be working at a centralized social media company, which recently rebranded to Meta to pivot into metaverse. During his career at Meta, or more specifically in Noble Finance, he created a Move language and DM platform to help build fundamental infrastructures for Web3. I guess something probably happened, so Sam and some of his colleagues quitted their job and started Mysten Labs, raising $36 million lead by A16Z at the end of last year to launch their own blockchain suite. Without further ado, let's welcome Sam to tell us more about Mysten Labs. So Sam, how are you?
Hey, Lingji, I'm doing great. Thanks so much for the warm introduction.
Yeah, just could you, quickly just introduce yourself, tell us a bit regarding what is Mysten Labs and why you guys quitted Meta to do it?
Yeah, absolutely. So I'll start with some of my personal background, and then that'll lead very directly into the story of Mysten and of Sui. So I've, I'm as you said, I'm the CTO and co-founder of Mysten Labs. Before this, I was a principal engineer at Facebook, working on static analysis and programming tools at first, and then working on Novi, Move, DM, everything related to that. So I started off my career doing a PhD in programming languages, and what I was doing specifically is working in this field of static analysis or building automated bug finding tools. So when I was a PhD student, I spent a lot of time doing some very cool and esoteric math about how you build these automated bug finding tools. And then I would implement the tool and I would go and run it on some open source code. And occasionally I would find bugs and beg developers to fix them. And usually they wouldn't, but sometimes they would. And I was very pleased with this, and it was great fun. But it was basically like very fun intellectual games, not something that was particularly practical. But towards the end of my internship, towards the end of my PhD, I had a chance to do an internship at Facebook. And this was back in like 2013 to 2014 when they were making the transition from being a web first company to a mobile first company, and discovering like, hey, actually, when we ship bugs into mobile apps, they sit there for much longer than in the web. In the web, we can fix it same day. In mobile, they're there for 2 weeks. And so they were investing in all sorts of techniques to try to keep bugs out of the mobile apps, including the static analysis stuff that I was working on. So I landed an internship there and got to do the same things I was doing in my PhD, but instead of begging, 1 or 2 or 3 open source developers to fix stuff, like my work shipped in front of tens of thousands of Facebook developers, and then they were giving me real-time feedback on, this tool, it's awesome what this tool can do. Like, could it also find this? Like, I don't like that it does that. And so I just got really hooked on this feedback loop between doing this cutting edge research, but then having it really make a difference in industrial practice. So I joined Facebook and continued to work on this static analysis stuff for a number of years, worked on buffer overflows, data races, null dereferences, taint analysis, like making sure that data coming in from a user request doesn't flow to the shell or to SQL without someone escaping it. And this was great work to be doing, but if you do this kind of work for too long, you discover like a lot of what you're doing is you're band-aiding design issues with languages, you're band-aiding design issues with frameworks, or like, migration that folks should really be doing. So I had a lot of opinions about languages and what are ways that programming language designers set folks up for failure? How do they make life difficult for developers? And how do they make life hard for people like me who are building these automated reasoning tools? And then how do we make folks care about automated reasoning and bug finding and verification? And so in 2018, I had a chance to put these ideas to work when I was asked to join the Libra project as a founding engineer. Back then, this was this big top secret Facebook project to build a global scale payments and smart contract platform powered by blockchain. And so they're bringing experts from all across the company and the areas they thought were relevant. So payments, distributed systems, cryptography, networking, and then also smart contracts. So they asked me like, hey, figure out what to do with this smart contracts thing. We can take this EVM Solidity thing and try to make it better. We can do our own language. We can try to retrofit a mainstream language, just figure out what to do there. And so as part of that, I led the effort to create the Move language, which I can talk a lot more about later, but basically like is a reaction to what we saw folks is trying to do with the EVM and with early smart contracts, but without many of the safety issues and with better expressivity and more accessible to non-experts and non-smart contract programmers. Then as part of creating and designing Move and building out that team, I got really involved into the protocol design for Libra and DM, and also got a little bit into applied cryptography. And this is where I ended up meeting all of my Mysten co-founders. So the Libra project was a very fun and interesting project to work on. The way it went is kind of interesting, where early on, it was, as I was saying, it was this very ambitious thing. We're like, let's build an Ethereum killer and then some. Let's build the global scale version of Ethereum. And we're going to have arbitrary smart contracts. That's why we bothered to design our own language. And, we're going to handle the world scale traffic. Like everyone in the world should have an account. And so like we really were designing the system for that. But as time went on, like both because of changing requirements, regulatory pushback, and some issues with Facebook's reputation, like the scope of the project changed a lot, where it was more, okay, we're going to build a payments network, and the participants in this network won't be individual users, but they'll be large entities that are operating wallets who do transfers off chain for privacy and then basically do settlement on chain. And so that had very different requirements in terms of what it needed from a systems perspective. You don't need to support a large number of accounts or transactions because you're just going to be doing a little bit of intraday settlement. You don't need to handle a lot of storage because you only have payments, and account balances between these folks are very small. And so the design of Move carried along, but a lot of the design of DM, like I think correctly overfit to these requirements because that's what we were trying to ship. And so the team that I was on, the Novi research team, like started to look ahead and think about like, okay, what are the things that once we get out of this payments only phase and think about a future system, like where will the bottlenecks arise, and like what is a system that can scale to the original Libra vision look like? And so we and I shouldn't say we, this is mostly work of my co-founders like George, like worked on things like NoWhite and Tasks, like what's a next generation consensus protocol that works much better than DMs does, and how can we come up with a new data model that lets us do better parallel execution than we did in DM, and things along these lines. And so we stuck around to try to see DM out the door because we all loved it very much, and felt conviction about the mission of the project and wanted to see what would happen. But also, like, we had been working on all these ideas for, like, how do we go beyond? And we could see there wasn't a path to production for DM at Facebook, and like we really wanted to get out into the broader world and put some of these system design ideas to the test, get Move out there, and get it being used in its intended capacity. Really building arbitrary smart contracts, being a better version of Solidity, and bringing this stuff to the masses. And so that was the genesis of Mysten. I jumped out with my co-founder Evan, who ran the research team at Novi and DM, George, who is like the distributed systems and security expert, who was doing a lot of this research on scaling, Kostas, who was a lead cryptographer at Novi DM and is doing lots and lots of work on, I think he may actually be on the call and can introduce himself, all things cryptography related. And then Adani, who was the product guy, who had all sorts of ideas for next gen things to do with Web3, and especially with a platform that could handle these sorts of, that can scale in the way that we wanted to. So that's the story of how we got to founding Mysten. And then why don't I pause there to see what the next questions are? I'm sure we're going to talk about the suite and other things, but that's basically me and then Mysten in a not so short nutshell.
I feel like I should just let you talking through like the whole hour, Sam, so I can just just sit there and listen, which is great. So I think you talk a lot regarding the early phase. The early phase, you guys are actually doing great researchers at Meta, and then I feel like okay, at that moment they're actually the birth of Mysten Lab, right? But the sector of like layer one are pretty like packed. There are a lot of like different protocols on doing that. Can you just tell us a little bit regarding like what Mysten Lab differentiates itself from the other, maybe more like classical EVM based layer one?
Yeah, exactly. So let me answer that question I'll give one answer for classical EVM-based layer ones. I would give a slightly different answer for layer ones that are trying to do sharding at the protocol level, like near like Polkadot or something else. And please ask me about that if you're interested. But
yeah, sure,
for answering this first thing, I'm going to paint all other L1s with a very broad brush and talk about what Sui does differently. So if you look at the way other the question we were fundamentally trying to answer with Sui is, we don't want a system that has, X TPS, and that's like the max that we can get. What we want is horizontal scalability, the same way Web2 services scale. We want to add more machines, and by add more machines, I mean for a validator participant in the network, like they add more machines to their particular set that they're using, then we should get more throughput and we should get more storage capacity, and that should just continue without an upper bound with commodity machines. We don't want to rely on horizontal scaling. We don't want to rely on vertical scaling in Moore's law. We don't want to have arbitrary bottlenecks that are there in the protocol where we're worried about what would happen. We just want to have this horizontal scalability property. And what we thought about is like, what do you need to change about the existing blockchain architecture in order to achieve this? Like, starting from the very bottom. And the main thing we thought about is that, or I think the main thing we're doing differently, and then everything else sort of follows from, is just having a very different data model. Like when you think about what these blockchains do, like what every transaction does, it's all centered around assets. A transaction is going to touch some assets, it'll read them, it'll write them, it might create some new ones, it might transfer them, but it's not going to have effects other than that, or like effects other than that are meaningless or sort of temporary. And this is very different from a conventional computing system. Like, if you're writing a compiler or an operating system or any of these sorts of things, like you have very different requirements. But here, like really it's every transaction touches this very small set of things, and that's all that it does. And so what you really want is a data model that makes that relationship super explicit. You want to be able to look at a transaction without even running it and see what are the pieces of state it's going to touch, what might it create, what's going to be read, what's only going to be written. And if you have that, then makes it really, really easy to execute transactions in parallel, because the relationship between transactions is dead simple. You don't have to discover it at execution time. It's just right there in the transaction data format. And similarly, if you have a first-class notion of asset, and that's what's actually in the database, then your data model can be very simple. You don't have to have accounts. You can have objects that have unique IDs, and you can use conventional storage techniques. You can shard by object ID. You can shard by the owner of the object, which is how we do it. Like instead of having an account that has objects in it, objects just have metadata that says the address of the owner, or this object is owned by another object, or this is shared and anyone is allowed to touch it. And so what we do is we have this data model that's oriented around objects that have unique IDs, and then transactions have to pre-declare the objects that they're going to operate on. And then what that lets us do is when transactions touch distinct objects, we can execute them in parallel. And then in some cases, we can execute them without even going through full consensus. Like one of the things we observed is that in other blockchains, the process is always, you get a bunch of transactions from users, you run consensus, which is n squared, and the number of participants on those transactions, and you compute a full ordering on them, and then you execute them. Usually you do that sequentially. That's what the Ethereum does, and one of the reasons why it's slow. Some newer protocols like Solana are trying to be smart about parallel execution, but fundamentally this first step is always let's sequence these transactions. But this doesn't actually make a lot of sense, because when you look at the workloads of smart contracts, most of them don't, or many of them actually don't require sequencing. If you and I are both doing a token transfer, there's no reason those operations have to be sequenced. And similarly, like if you're minting an NFT, like there's no reason that has to be sequenced with me minting some related NFT. A lot of this computation is actually, these computations actually commute with respect to each other. And so we have a system where in the data model itself, you can tell whether the transaction is doing that kind of computation or not. And if it's not, then it doesn't have to go through consensus at all. It doesn't have to be sequenced. We use a weaker systems primitive called Byzantine consistent broadcast that can be done in under a second, and that's linear in the number of participants instead of quadratic in the number of participants. So basically the two things we're doing, what we do is we just do a ground up rethink of what are blockchains trying to do, what's the data model that supports that, and then how do we leverage that data model to execute transactions in parallel in all cases, and then in some cases to sequence them in parallel, or just and avoid consensus altogether when that's not needed. So I think this is what's different. Whereas in other systems, like you're somewhere in the protocol, there's a bottleneck. Usually it's like when you get beyond a single machine, there will be some global Merkle tree, and maybe you need to compute the new state root of the Merkle tree after every transaction or every block. And then if the Merkle tree grows beyond a machine, then the protocol starts to slow down and is blocked on IO or something else. Or maybe you don't know how to do sharding, so you can't go beyond a single machine. Or you have some GPUs and you need Moore's law to make the GPU faster so you can do your proof of history faster. So to go at a very, very high level, like that's the thing that we're doing differently. Like we want Web3 to be able to grow with the demand of users and of companies that use it. And so we don't think it's acceptable to be capped at a single TPS number. We want Sui to be able to grow with the demand that comes from the market.
That's awesome. That's awesome. Really, really, very detailed information for me to understand, how Mysten Labs, especially Sui, actually approaching this kind of horizontal scaling things. I would like just, to dig one more level deeper into that, because I know, Mysten Labs is actually building this kind of fundamental infrastructures for Web3 to actually tackle challenges and accelerate development and adoption of decentralized services, right? Especially for this kind of Sui based on Mysten Labs design component, which you have already talked about, this kind of horizontal scaling tools. So when I was actually reading your guys' white paper, actually two tools actually really brought my attention. One is called NoWhite, which is like ensuring the availability of data submitted to the consensus. The other one is called Tasks, right, which is actually agree on specific ordering of the data. Can you just talk a little bit more regarding how this actually are helping to resolving the scalability challenges that like most other blockchains are actually facing at this moment?
Yeah, absolutely. So I'm not the consensus expert. That would be George. So I'll muddle through this question as best I can, but please forgive me if, especially the more technical folks in the audience, if I say something wrong here, and come to George for clarifications. So with NoWhite Tusk, like the key observation it's making, like from a high level perspective, is that when you look at consensus protocols, they're basically trying to do two different things. So one is there's a bunch of validators that are participating in consensus, and then they're trying to make sure that they're all on the same page about what transactions we're talking about. And then the second thing is let's agree on an ordering between those transactions. So first is agreement on what transactions are in scope, and then the second one is sequencing. And in consensus protocols before Narwhal Tusk, these two steps were conflated. You do a little bit of each at the same time. And the sequencing part of this operation is O of n squared and the number of validators. Whereas in theory, the dissemination part, making sure that you all agree on the set of transactions, is O of n. And so if you're doing the dissemination part as part of the sequencing, then you're taking O of n squared to do something that should be O of n. So the key thing that Narwhal and Tusk is doing is it breaks this out. And that's why we keep saying like Narwhal and Tusk are not the same thing. Narwhal is the part that does the the O of n transaction dissemination via consistent broadcasts, which doesn't require ordering. Then once everyone's on the same page about what transactions are there are basically very short references that refer to, okay, this is transaction 1 and this is transaction 2. And then you can use whatever consensus protocol you want to order those. So Tusk is one that is particularly designed to have this separation, but you can also retrofit hot stuff or any other Byzantine fault tolerant consensus protocol on top of that. So that's the main thing Narwhal Tusk is doing differently from other consensus protocols. And in SWE, we're using this because we have great scalability for transactions that don't require consensus via this mechanism I described of executing and committing transactions in parallel without sequencing. But of course, like you're going to have things like DEXs and NFT marketplaces that do require sequencing. If you and I are both hitting a DEX, somebody has to decide who gets the first price and who gets the second price. So you're going to need consensus. And so of course, like we want that part of the system to scale just as well as the other part. And so we're using the best in breed with Narwhal Tusk. This recently won the best paper award at Eurosys 2022. And like there are several extensions on top of it that the consensus folks are working on as well.
Yeah, this is really amazing protocol. While I was actually reading it, I feel like I learned so much. The more amazing thing is while I was actually reading it is I feel besides you guys are actually using it on the SWE protocol, which you guys are building on top of that, you guys also are actually building strategic partnership with other existing networks, for example, Celio, to actually integrating Mysten Labs technology through open source, NoWhite and Tasks, right? So it just, sounds to me, this is actually, core value. You guys are building Mysten Labs network effect. Why you guys eventually decided to open source them and help others to actually resolve in similar potential scaling issues?
Yeah, well, the mission of Mysten is building foundational infrastructure for Web3, and we take a component-wise approach to that, where like Web3 isn't just one thing; like it's a series of cooperating protocols, cooperating components, and the ethos of the space is collaborative. And there are many components and many protocols. I would say maybe all of them, in fact, that benefit from having a larger community, that benefit from having more eyes on it, that benefit from having more core contributors. So for us, like the two big things there are, and the things that we're working with other folks on are Move and Narwhal. So for Move, of course, like I was the creator of the language and we have many of the core contributors. Any language, like the most valuable asset it can have is its community. You could be the best language technically in the world, but if you don't have the community of developers, if you don't have the community and ecosystem of tooling, then your language isn't going to win out. And so for us, like any chance that we have to promote Move and broaden its adoption and spread it in other places, then we're going to do that. And we're the leaders in the development of the language and figuring out what's next and helping folks use it. So like, of course, we have partnerships where we help folks integrate Move into their blockchain. And I'm sure in the future, we'll do many, many other things with Move. And so for Narwhal Tusk, it's somewhat of a similar dynamic where consensus is a very, very key component. Like you probably don't want to be the only one using a consensus protocol. It benefits from being hardened in production in more settings, being used in slightly different ways, having lots of different eyes on it. Like if you look at the way Tendermint is used in Cosmos, for example, like I think it's great that they've really hardened the implementation and that many different protocols have built on it and sort of like stood the test of time. And so we want that for Narwhal too. Like, of course, we want to leverage that in SWE, but we also want other folks to take the work we've done and be able to speed up their networks. Like Web3 benefits from everyone having more TPS and more throughput and more solid fundamental components at the base and not getting hacked. I think the hacks and security issues and slowdowns don't benefit everyone. Or don't benefit anyone, sorry.
That's a part I love Web3 the most. Everything's open source. You can just, go crack it and then build on top of all other things that, giant like you already built on top of. The follow-up question I have is, when people are talking about Web3, they're always thinking about there's actually this trilemma regarding scalability, security, and decentralization. We're talking about all this kind of horizontal scaling things, which through NoWhite and Tasks, which can be solved from security perspective, you guys have the move language, which is actually addressing a lot of re-entry and bugs that when people are actually developing Solidity, they used to have. So I guess, when people are thinking about Chalamas, there's always like one or the other. So the question people might have is like, because all this kind of great things Sui or whatever Mysten Lab already have, how decentralized is Sui? How decentralized is the open protocol you guys are actually building at this moment?
Yeah, no, that's a great question. I mean, I think decentralization itself is a thing where there are many different facets to it. So like, let me talk about each of them and like in which cases we think we're doing something fundamentally that's improving there, or I think like the narrative just has to change a bit. So one definition or like one facet of decentralization might be the number of validators who are participating. Another might be the number of distinct entities that you have to corrupt to violate the BFT assumptions. And yet another might be outside of the validator set, how easy is it for folks to check the work of the validators and replicate the network and check what's going on? How easy it is to scale the full node ecosystem might be another way to put that, considering the way other things work. So, and then another might be what's the bar for becoming a validator? Like, do you need the latest hardware in the world? Does it cost millions of dollars or tens of millions of dollars? And so for all these things, basically like more participation, lower barriers to entry, whatever is better. So I think for Sui and for other high throughput chains, like the barrier to being a validator is going to be higher. I think this is fundamental and there's no way around it. Like you're not going to process tens of millions of transactions or hundreds of millions or whatever without having some hardware. I think it's ideal without having some heavier hardware and more stringent operational costs and expertise. I think you don't want this to be, but you need to buy a supercomputer and only people who have access to the supply chain of the supercomputer or like the best mining hardware can access it. But I think it's okay if basically to be a validator, you need to be able to run a small cluster or even perhaps operate in a data center at scale. I think this is just fundamental and like something that folks have to get comfortable with if we're going to have high throughput chains. So I think like that's Sui's perspective on this. And I think for anyone that's trying to build a high throughput chain, like this will be true. Then in terms of scaling full nodes or like scaling replication, I think this is something that folks think about a lot less. And it's something that is actually like really, really hard because you can say, sure, it's expensive to be a validator, but if you're like, now you need to run a data center to check the work of the validators, you're back in the world of the oligarchy that we have in Web 2 today. So that doesn't seem very acceptable. So in Sui, we have a very different story on this that we think is compelling, where we have something that we call a sparse node, where a full node replicates all of the state and executes all of the transaction. A sparse node starts from a set of causal roots, like addresses, like objects, and it can replicate only the transactions that are relevant to those objects. And the reason this is possible is because of the data model that I described. For each transaction, you know what objects are going into it, and you know what's coming out. And so you can say, give me the transactions that are touching the objects that came out of the other ones I care about, but not anything else. And so, for example, every wallet is a sparse node, can basically check that the history of the state that it knows about or cares about is trusted. And then if you're someone like a game developer running a game server, you can run a sparse node that replicates the state of your players and your game state, but not worry about some DEX that's happening over here or some other game that's happening over there. So we feel like this sparse node is a really good answer to the scaling, the scaling full nodes or scaling replication beyond the validators problem. And like that's something that's really, really important. That's a really aspect of decentralization that folks often ignore. So I think Sui is, on the first question, on the number of validators, the barrier to entry to being a validator, Sui is going to have similar issues to others. Like you just need a higher barrier to entry if you want to be high throughput. But I think we have a much better story on this scaling replication thing. Let's see a couple hands up. Let me take these.
That's what I'm about to say. I would like to open the floor to the audience. If you have any questions, feel free to type in the chat or just raise your hand. The first one, Kaidu.
Thank you, Sam. I first know about Sway from Zero Knowledge podcast. One question I had, probably you addressed it a little bit, but I didn't fully understand, is about the parallelization. So my understanding of parallelization is some transactions doesn't go into full consensus, but some certificate is issued. And my question there is, let's say you send me 100 USD, and then there's no share object touch, so I just have a certificate essentially on that transaction. What happens if you send that the same 100 USDC to, let's say, a Uniswap swapping pool, which touch a a shared object, and that goes into full consensus? Does it mean like my $100 never arrived? How would that work?
Yep, good question. So let me walk through what would happen there. So the start state here would be I have an object whose type is coin of USD, and it has a version number. Let's say that's version number 1, and it has an owner whose address is me. So if I'm trying to send a transaction that's sending it to you, what that's doing is it's just mutating that owner field to be your address instead of my address. And then if I were sending it to this DEX and trying to make a trade, then what's going to happen is it'll go in as an input to the transaction, and then it'll end up being destroyed and merged into some other object of the same type that DEX has. So what will happen is one of these transactions will win, and there are 3 different things that could happen. So the first one is one of the 2 transactions wins. So what could happen is the transaction that's sending the money to you gets 2+1 signatures first, and then it gets committed, and then the transaction that's trying to send that coin to the DEX will fail, because it'll say, hey, you were trying to send this coin with version number 1 to the DEX, but I see the version number of the coin is 2. Every time an object gets used in a transaction, its version number gets incremented. So it'd say, okay, sorry, yeah, the object of this version has already been used. Then it could also go the other way, where the DEX transaction wins. Same thing there. The version number will get incremented. You'll see the coin as the input to your transaction has the wrong version number, so that transaction will fail. The other thing that could happen is I get F signatures on the first transaction and then F signatures on the second, and then it's not possible to commit either of them. We call this outcome equivocation, and what will happen then is my coin object is locked. It can't be used in any transaction until the end of the next epoch, in which case the validators will forget about the locks on this coin. Neither of the transactions will get committed, and I can submit a fresh transaction to do it. So this equivocation outcome, it's prevented by construction in the client software. The only time this will happen is if a user is trying to do something malicious like this, like try to do a double spend, and then the protocol will catch it, but the user's objects will get locked.
I see. But let's say you send me the USDC, let's say like a week before you submit the second transaction. So as me, which is a receiver end, do I need to keep monitoring the chain and submit this sort of like conflicting transaction on time?
No, you don't. When I try to send the second transaction a week later, I'll be trying to send this coin object with version number 1, but then the latest version number of the coin will be 2 if you've done nothing with it, or it'll be higher if you've then gone around and sent it. So it'll just say, the way the system works is it keeps track of, okay, I know about every object and what its current version is, and then I hold locks on objects that are being used in a transaction but have not yet been committed. And then if an object doesn't exist at that version, the system at all just says this object doesn't exist, like this object has moved on, it doesn't exist anymore. So my transaction would just be rejected.
Got it. So the version number is updated on chain then, or the
exactly. It's part of the object metadata, and every time an object goes into a transaction, its version number gets incremented, even if the transaction aborts, like it does a little bit of computation and then runs out of gas or overflows or something.
Got it. Thank you.
Yeah, of course. Good question.
Next is Aaron. Aaron, you still on mute.
Was on mute. Okay, let's try this again. Hey, thanks for your time today, Sam. I wanted to ask you a little bit, sort of a broad question about blockchain, but then also getting back to SUI in particular. If you look at blockchain designs today, and we've sort of been circling around this with parallel execution, but if you look at blockchain designs for the most part, you have this ordering of transactions, but then you actually have to execute the transactions and run the code that's in the smart contracts. And it's pretty easy to do that as long as the smart contracts are sort of mutating an address or maybe doing something with a liquidity pool, but really kind of low throughput compute, right? But you could imagine that maybe somebody puts together a transaction that has an optimizer sitting in it or has an image classifier sitting in it. And, instantly we already know that that's not going to work on, say, a chain like Ethereum just because of gas fees, right? And there's a limit to that and how much compute you can do in a block. Where do you see, with all of these sort of purpose-specific chains that are coming online, but then also with general purpose chains like yours that do support higher throughput, where do you see the industry heading broadly in terms of scaling to use cases that need more compute?
Yeah, so I think for use cases that need more compute and that compute can be organized in a way that's friendly to parallelism, I think SWI and perhaps other feature designs can do it. I think as long as you have computations that are parallelizable, it's worth it to do massively replicated computation like blockchains are doing. But if you have a computation that's inherently sequential, then there's no design in the world that's going to make that faster, right? Like, say you have an image classifier that just like the workload is just, it takes, 2 minutes of sequential work and there's just nothing you can do about that. I think then the question becomes, how valuable is that work? Is it valuable enough to actually do like the 100x replicated computation or whatever redundancy factor you have in the blockchain is? And if it is, like, that's the great thing about the blockchain, like the economics will be worked out in a way that will price that gas fees so that the slowdown, the fact that you're occupying one core of the validator, churning through those 2 minutes of computation will be priced in, but like, you'll be willing to pay the high price because it's worth it for you. My intuition says that low computation, easily parallelizable workloads are things that like, those are going to be slam dunk use cases for blockchain. I'm a little more skeptical about things like training machine learning classifiers or other stuff, unless it's possible to parallelize it or like to chunk up the computation into small little bits that you don't occupy a core for too long, or so that you don't degrade the service of others. But I think if you have something that's really sequential, like that's just going to be hard no matter how good your blockchain design is. That comes down to like how fast is your VM, and then like how fast is your processor, and like we can make incremental gains there, but at some point like you just hit fundamental limits.
Cool. Yeah, thank you. And I guess a follow-on question. So, so my startup Iron Mill is basically building technology that gets at this issue of lots of replication of computation, because to your point, you may not want to replicate that, machine learning classifier 100x. Maybe you do want to replicate it 3x though. So what we're building is tools that give you almost a slider to give you different parameters about how things execute. In terms of, for startups that might want to work with you guys to build things on your platform, obviously there's a lot of documentation and white papers to read. Is that the place to start, or are there other resources we should be aware of?
Yeah, the documentation and white papers are definitely the best starting point. There's a very active Discord community where like if you have questions going through that or have more focused things, and like that works very well. We're also very active on Twitter. And then of course we have a partnerships team to work on a grants program. Like there are channels in the Discord to ask about these sorts of things. And of course, like this group is all friends. Like if you have ideas or like opportunities for collaboration, I'm more than happy to connect anyone here or like friends of them to our partnerships team to discuss ways that we could work together with Sui or with Mysten.
Cool. Okay, awesome. Thank you.
Yeah, of course. Good question.
Yeah, thanks, Aaron. I just have another follow-up question on what Aaron has already talked about, because Sui or whatever you guys are building really focus on parallel computing. Is like, what kind of product you think you actually expect developer to actually build on top of Sui? Is that like DeFi, is that game, or is there actually something else?
Yep. So it's a general purpose L1. We hope all of it. And like, I think the market for block spaces is early and evolving. Like you'll see a lot in our public materials and like in our partnerships that we are very focused on gaming. The reason for that is basically that, when we started Mysten, we did a lot of talking to folks who wanted to build on blockchains and had ideas about crypto. And the one that we felt that was least served by the current offerings was gaming, where here like for games, there are very natural use cases. Like game businesses in a lot of cases make their money by selling digital assets, and a billion-dollar business from doing that. It's very easy to see how to map that onto NFTs and things you can do in crypto. But then if you're a game with 10 million users, which is a pretty small game, and you go and each person wants to do one on-chain action each day on existing chains, that's just going to be cost prohibitive right out of the gate. And so what we found is there are a lot of folks that's like, well, we'd like to do something, but there's just not a platform that can handle our scale. Or we start off with these grand ambitions of what we can do, and then the ambitions get watered down by the limitations of the platform, and it ends up being a not very compelling offering. So we could see there's a very clear demand for something that can actually meet the scalability requirements that these games will have. And then there's a big opportunity in that you pull one or two of these games and you probably have more users than all of Web3, just because these games are so large. And so that's something we're very, very focused on. And then not just in like the systems aspect, but like also in the programmability aspect. Like game developers don't want to become smart contracts experts or blockchain experts. They want to build fun games and compelling products. So we want to have a development experience that is more like a Web2 development experience, or that abstracts away from some of that stuff. And so that's why we're very excited about Move, because it basically takes away many of the security issues by construction. And then also like it has an opinionated compiler and toolchain that guide you toward doing the right thing. And then we've made some specializations to Move in Sui that are friendlier to folks in the gaming audience. Like if you're a game developer, like everything you do is the scene hierarchy, or like these tree-shaped structures, where like you have a map, and then the things on the map are child objects of the map, and then the player is somewhere on the map, and then the items it has are children of them. And so Sui is built around, like we talked about these objects in the system thing. You program directly with these in the Sui version of Move. You write a main function that takes some objects as input, and then you mutate these objects, and then you transfer them, and then they can have parent and child relationships. And so this is very familiar to someone in the gaming world. I mean, there are verticals we're very interested in besides gaming as well. So I think one of the use cases folks have talked about forever with blockchains, but has never quite materialized, is payments, and especially micropayments. Like, I think there hasn't been a platform that made it easy enough to onboard users or made payments cheap enough for this to actually be realized. But I think like with games, like using payments for creator monetization, I think there are like also lots of other things along these lines that make sense. And then we're also very interested in like commerce and brand. Like obviously NFTs are a huge thing. There's lots of brands want to do NFT drops, or like cross promotions with other brands or games, or like, sort of shared login. So all of this stuff, our product team is looking at. Like games you hear about a lot because like the scale issue, both in terms of throughput and latency, really comes up immediately, and we can serve. But we think lots of other consumer and enterprise use cases that both weren't possible before because of the systems aspects and because of the lack of accessibility, the programmability, will also become possible on Sui. And then of course, like conventional Web3 use cases, we're very interested in that too. Like you need DEXs to drive the economic engine, and tokens issued to drive the economic engine of the chain. We care about other smart contract use cases as well. It's just, we talk about those less because like folks will come on and build these things, and we're pursuing partnerships in those areas as well.
Got you. Awesome. Yeah, when I was actually reading around, I saw you guys have the same Sui Echo, the Sui developer kits, the Sui dynamic NFTs, all this kind of two packages that you actually make sure it's actually easier for game developer to build on top of Sui. I mean, personally, I just have a quick question on game, because I was actually working on game infra at Amazon. So basically, when people are actually talking about Web3 games, right, they think blockchain actually can do two parts. One is actually allow people to easily like trade NFTs and monetize NFTs, which is actually part of the Web3 game content. The other part that people are really talking about is something called on-chain games. So basically, the entire game is actually settled on-chain, which is like, I don't know, it sounds to me it's just not achievable. Like, what's your opinion on like on-chain games? Will this kind of high throughput Sui is providing can actually help addressing some on-chain game bottlenecks, or you think it's actually a more classical way, like Cosmos, you can actually launch a specific chain which is dedicated for high throughput for on-chain games. So what's your opinion on on-chain games?
So I think it's a mix. Like our gaming partners are much more creative than me, and the ways they want to use what we're building surprise me. So I'll just give you a couple of examples. So like there are the obvious things like we mentioned so far, like, okay, we have assets in our centralized database. There are opportunities for moving those on chain for interoperability and like using them across the games that are made by the same publisher, or like giving them access to more liquidity by selling them at a marketplace, or like, sort of the equivalent of having your Babe Ruth baseball bat that is then purchased by a fan, like, someone wins an esports championship with a character and then can be sold to someone. So those are sort of like the obvious ones. But then there are folks doing interesting things like anti-cheat technology. Like a lot of games are primarily client side, and people figure out how to hack that on the client side, and generate themselves infinite coins or rewards. There's a really funny case of someone doing this with FIFA. Like you earn coins for winning FIFA games, and they figured out a way to play like millions of games a second locally and like destroyed the economy. And so there are interesting ways to enforce that scarcity at the blockchain level, like replay some scenarios of like, we know the client started in this state and then it ended in this state, but that's outside the parameters of what's possible, and use the trusted computation of the blockchain to ensure that. And then there are things like things that I mentioned before, like creator monetization or like player monetization, where maybe it's not like it's actually hard to give your players money. Like it's easy to hook up a credit card so they can give you money, but going the other way is actually quite tricky. And so there are a lot of opportunities that get opened up by that, where you pay players like either with a token of the game or the native tokens. It enables new ways to onboard players and new revenue models for games to try to start up. So, I'm an infrastructure guy. I don't claim to be the most creative in this area, but I'm always impressed by the vision that game folks want to have in doing on this. And we're most focused on building out the feature set that'll let them do whatever they want to do.
Sounds awesome. Like I said earlier, the floor is open. So if you guys get tired of all the questions I'm asking Sam, use your curiosity and raise your hands. I'm more than happy to hear other questions from the audience. But at this moment, there's no more. So you guys have to just follow the boring question from me. So the next one I have is like, you just said, you guys will actually launch Testnet Model, which is a big congratulations on that. Any other big milestone that as an audience like us can expect from Mysten Lab in the future?
Oh, sorry, we're not launching our testnet tomorrow. We will announce the date when we will launch our testnet tomorrow. No, it's okay. I just wanted to make sure I don't get in trouble with the wrong folks. So yes, of course, like we have the testnet coming up, and as part of that, like we both want folks in the community to be writing validators. We're also gonna have a series of Move building challenges to really show them like show the capabilities of Move, and especially like with this new version of Move that we're using in Sui, and like all the cool things that it can do and the products that can be built on top of it. So we're very excited for that. in addition, like there's interesting partnership announcements that'll be coming down the pipe, like both as like part of testnet and then beyond, like some of these use cases that I vaguely alluded to, like you'll see the names behind them and more concrete details about what's going on. And then we're hoping to have a mainnet launch before the end of the year. We're still trying to nail down the exact date on that. And of course, like we need to really work in testnet to get the software to be very stable, to be very performant, and reach a high level of operational excellence among our validators. But those are basically the milestones that are coming up for us. We're in execution mode and excited about each of them.
Sounds awesome. I saw hands up again, so Kun.
All right. Thank you, Sam, for the awesome talk. So I'm really curious about your view of the future of Move language, especially on onboarding developers, comparing to Solidity that has already a very mature infrastructure and development tool sets for developers, and also Rust. So what's your view on the Move, especially the future? And the second question I have is, what's your view other Move language based L1s, namely Aptos, and what do you think your main differentiators?
Yeah, those are both great questions. Let me address the Move Solidity thing first, and then I'll talk about Sui versus Aptos second. So for Move versus Solidity, like there's this meme in the space that Solidity has these massive network effects and that it's already won and that like anyone else is gonna have to overcome it. When you actually look at the numbers, and the numbers I'm referring to here come from the Electric Capital developer report from last year, there are 4,000 active Solidity developers. Now, this is very, very small in comparison to other developer communities. Like, I think there's 18 million JavaScript developers. There are 12 million iOS developers. So, this is, I think like these network effects are overstated. And the other thing too is that it is hard to convince these folks to switch. Like these folks are very well paid. They already know Solidity. Like they have their pick of a lot of interesting projects. Like, I think it's not especially if you're going for consumer and enterprise grade adoption, it's not the best strategy to try to convince these folks to switch. It's much, much better to try to grow the pie. Like even if I could switch snap my fingers and make every Solidity developer be a Move developer tomorrow, I think that still wouldn't be enough for the needs of Sui and some of the customers that are building on it who really need like these larger developer communities. So we take a two-pronged approach. Like our first thing is figure out how to grow the pie. And the way we do that, I sort of alluded to before, is that we really try to make Move friendly for folks who are coming from a more conventional developer background. Like there are some things that are fundamentally hard about smart contracts. If we can take and especially things relating to security and chain specificity, if we can take those away in the language design and the tool chain, or help the compiler or like the Move prover or other things guide you toward the right path, then we do that so folks will have an easy way in. And then the other thing, for bringing in folks from the Solidity and the EVM world, like I think folks in Web3 are great technologists. Like they see when something is new and provides an improvement. And so I think like the very best folks are curious about, Move is doing some very interesting things. It was specifically designed to solve some problems with Solidity. Like I know about those problems that have been affected by them, so I see them and I want to switch. So I think we're doing both. So we're both like trying to get as many Move developers as possible and bring over Solidity developers. And this sort of leads into the next question. One thing that's interesting about Move is that with Solidity and with Solana and with basically like any of these other smart contract languages, they're very specific to the platform that they're designed for. They bake in things like the address format, the transaction format, like sometimes even the consensus, the cryptography that's used. And so if you're trying to build a next-gen platform that's addressing some limitations of previous ones, it's very hard to use something like the EVM without inheriting some of those limitations. And especially for us, like the data model of the EVM for assets, like assets are represented via hash tables. Like you have a hash table where the keys are addresses and the values are bytes in the hash table. And so if you're trying to write a program that's working with these assets, it's going to index dynamically into these hash tables at runtime. And something that we want to do, like support transferring two NFTs in parallel, that won't work if you have the EVM data model, because what you're doing is you have two transactions that are both hitting the same hash table. That's not parallelizable. Whereas if you have an asset-centric data model, then you can parallelize that. So with Move, we've tried to we succeeded in baking like no platform specific details into the core language. It's a very, very minimal core language where it's got structs, it's got addresses, it's got integers and booleans, and it's got some instructions, but it's got nothing else. It doesn't overfit any details of a chain. So that makes it much easier to use in a cross-platform setting and let people experiment with next generation ideas around how should we design a more scalable blockchain? How should we design a more user-friendly blockchain or a better one? So it's fundamentally cross-platform. And so like we're using Move and Sui in a certain way, and then Aptos is using Move in one way. There's Starcoin and OL, which are also using Move, but have sort of different flavors in the way that they've instantiated. So it lets you build out as a developer. It lets you take your skills and use them across multiple blockchains. You can also reuse the code, like reuse some libraries. You can reuse the tooling without having to commit yourself to one platform for forever, because it's a rapidly evolving space, and you don't just want to have to pick one horse. Like, you'd like to be able to do all of it. So I think that's one thing that's going to be really huge for Move. It's not a good recipe for building a large developer community by basically overfitting to one platform. And so for Move, like, we really don't want to do that. Okay, so that's the Move part. Let me now talk about Aptos versus Sui. And then I alluded to this a little bit in the previous comments about, like, when we came out of Facebook and like, what did we decide to do, where all of our team worked on the DM platform. We worked a lot on the design of it. So we really understand what it does well and what it doesn't do well. And I talked about the way that these changing requirements, like around being a settlement layer and like caring more about compliance and payments than general purpose use cases, and like how those influence the design. So like, there were explicit conversations at DM where it's like, we don't have to worry about scaling beyond multiple machines or having lots of storage, because we only care about payments, and like, we don't need that for those things. And so like, when we came out of Facebook, like, of course we looked at, okay, we all know DM very well, like the software is ready, like we could build on this and go to market quickly. But then like, when we were at the same time talking to folks in the gaming space or elsewhere and seeing like what they need, like what do they want to do? I've got 10 million players and I want to do these many on-chain actions for each player each day. We're like, we might be able to get them to come and build on our platform, and we might be able to handle their traffic. But what happens when the second player that wants to do that comes along, and the third one and the fourth one? We'll have to either jack up the gas prices or tell them to go away. And we don't want to have those conversations. Like, we want to make sure we can scale with the demand for our platform. And so that's why we decided to start from scratch and do the Sui thing. So I think for Aptos specifically, there are some or I don't want to say Aptos because I'm most familiar with DM and not as familiar with the changes that they made since then. There are a couple of problems that I anticipate coming up. So the first one is sharding. Like, there's a lot of things in the DM design where you assume that there's going to be a single machine and that you can compute a Merkle tree efficiently because everything is on that machine. And as soon as that has to go across multiple machines, it's very, very hard to, or at least back then when we were working on DM, we weren't sure how to do that efficiently. And that may be solvable, but the way we approach that in Sui is like, let's just change the architecture so we don't have to solve that problem. There are also issues like state bloat, where sort of similar thing, where like, you might need to grow the storage beyond a single machine. And also like, you want to make sure that if folks allocate a bunch of memory, then they're incentivized to clean it up later. And that if you pay money to the validators to allocate state, and at one point in time, then the validators who are still storing that data, who may be different years in the future, should still get paid for that somehow. And we looked at things like implementing rent and DM, and it just really degraded the user experience and was quite complicated. And like, it didn't solve this problem particularly well. And so there too, we're like, okay, we got to make sure we build in a way to solve this problem from first principles in Sui. And I can talk more about the storage fund thing that we're doing to do that, if it's interesting. And then another one is this problem that I've already talked about of how do you scale validation outside of the validator set? Like DM, like all other blockchains, is very based around this full node idea. And running a full node is cheaper than running a validator, but not so much cheaper. Like, you still have to have as much storage as the validator does. You still have to process all the same transactions the validator does. And it's hard to figure out how to do that, how to make that a lot cheaper, unless you can have something like the sparse node solution that we have, where you can really scale validation and continue to be decentralized as you have a high throughput chain. So I think, like, to paint with a very broad brush, like, the big difference is that Sui is designed to grow with demand, and with DM, like, that wasn't a requirement of the system, so it wasn't designed in this way. And it may be possible to retrofit the system to add these things on, but when we looked at doing that, we thought that it would be easier to start from scratch than to try to do that. Of course, like with Move, we still use it because Move is this cross-platform thing. It's very easy to take it and put it in a different system that's leveraging it in a different way.
Very interesting. Kaidu?
No, I think you answered my question there. I was gonna, since it's recorded, I thought Quinn's question, you may not take it too in depth. I was gonna ask, like, if a developer was choosing between Aptos and Sui, what's your pitch to let them build on Sui? I think that was a very, very good answer. But if there's anything else you want to add, feel free.
Yeah, so I think, as you said, like, the answer I gave would be the one, but I would say, like, don't listen to the pitch, like, try out the experience of building on both and see both, like, what is using Move like on each, like, what do the examples look like how do I feel writing this code, what are the things that I can do, what are the things I can't do, and then think about, like, what happens when my application gets thousands of users, millions of users, or whatever else, and like how the gas fees are going to change, or how the platform is going to scale to handle that.
Thank you.
Oh, thanks, Kaidu. I just want to add a couple more words when you're actually saying the storage part. When I was actually reading your guys' white paper, if I understand it correctly, when you are actually using the storage, you pay for that. But after you actually free the storage, you actually get your token rebated back. Am I correct? Is that how it works?
Yeah, so let me explain the storage fund idea in more detail. So when you allocate storage on Sui, like on many blockchains, you pay a fee per byte in storage. And on Sui, like we have a separate gas price for storage and a separate gas price for computation. These are separate commodities. You shouldn't conflate them. That leads to all sorts of problems. When you pay this money, it goes into something called a storage fund. You can think of this as being a special account. And then the validators earn staking rewards on that storage fund. And this is how we solve this problem of if you allocate the storage today, but then there are validators 20 years in the future, they're still storing the stuff that I put on there. They should somehow get compensated for that. They should be excited that someone allocated storage because they'll get paid for it. And so that's how the storage fund does this, is that there's the storage fund that's proportional to the size of the data they store, and then they earn staking rewards. They can use that to go buy more hardware or upgrade their disks or whatever else they need to do. And then there's the cleanup part where I shouldn't just be able to pay and have like I pay and I put data there, but then like what's going to incentivize me to clean up after myself or someone else to clean up after me? And then what we do there is when you free the storage, you get back not exactly the same you paid, but a slight amount less, like let's say 90% of what you paid in. And so if you allocate some storage and then it's no longer providing value for you and you don't need it anymore, you'll be incentivized to free it and get it back because you'll get a cash reward. And here, the important thing is that, and if you do, Ethereum has something like this where you get a discount on the gas for a transaction when you free storage. But here, like you get a direct rebate. So that is a much stronger incentive. You don't have to find some transaction that you get a discount on, like you can just get that cash back directly. And so in the tokenomics paper, we proved that this is economically equivalent to a rent model in terms of the behavior it incentivizes, but the UX is much better because rent is very annoying where as a user, you have to worry about like going in and topping up the rent on this account. And then like if something goes away, you have to have some scheme for putting it back. And then you can't ever actually delete all of it. You have to remember the hash of it somewhere. So that someone can actually come along and reinstantiate it later. And then if it's small data, like the hash may actually be bigger than the data that you deleted. That's the sort of analysis we did at DM where we're like, 80% of the overhead of this data is in the Merkle tree. So if we try to implement rent, then we're actually not going to save very much data and this won't work well at all. Like this is one of the things like in the DM architecture where like we just got to do something differently because like the bad UX of rent is bad enough, but then like it's not even solving the problem that we care about here.
Of course, very interesting. Yeah, I will highly suggest everybody to read your guys' white paper to actually understand more. I learned so much from it. I would like to close the chat from a more like bigger picture questions. So I know you guys you guys used to be from Meta and you try to deliver NoWhite, DM, Libra. It just wasn't very successful, or maybe I don't know whether it's successful or not. It just what kind of roles did you think this kind of big tech companies will actually fit into Web3? Did you think beyond Meta there are other big like big like tech companies can be successful to launch any Web3 related project, or they should just be like infrastructure computing providers? Like what kind of role you think the classical tech companies should play in Web3?
Yeah, so I think it'll be some of each. So definitely like there are Web2 companies that are doing lots of product development using Web3 primitives. Like, you mentioned Facebook, like their long play is the metaverse. I'm sure that'll have many components of integrating Web3, but then you have more direct things like you have Instagram profile pictures that can be NFTs, and like there's all sorts of different chains to integrate with for that. And then I think they also have some interesting ideas around creator monetization or DAOs for content or DAOs for governance. So like, some of the very thorny decisions that Facebook has to make in terms of content moderation or like things like that. Like that seems like a good way to bring in Web3 elements. And then you mentioned infrastructure providers, like, yeah, like the Googles and like Google especially, has announced some recent Web3 initiatives where they make it easier for folks to run validator nodes. I think they're going to do things like indexing on-chain events and providing scalable reads. I think that I expect that to grow a lot in prominence and for other web providers to do the same sorts of things. And then like you have is it Twitter or Blocker? I get confused by how it goes these days where like they're going very deep into Web3 and like integrating that with the various things that they do. So I think it's just emerging. And then you have folks like Stripe who, did Bitcoin at first and then for a long time didn't do it. And now are just getting back into crypto and crypto-based payments. I think it's a little bit too early to say, and it's really going to depend a lot on what the particular company is doing. I think ultimately like Web3, the best Web3 stuff, like Web3 won't be front and center. It'll give you new capabilities that fit naturally into the products and you won't even know that you're using it. And the stuff that we do will be boring, but very reliable and very cheap pipes that you use to do things better than before, and that it won't be so in your face. But that's my take.
Got you, got you. And the last part is more about like the regulation part, right? I guess when in Meta, there are a lot of regulation actually related to how actually Meta should actually launch their own chains, right? Like what's your opinion regarding like what kind of regulation you expect in the future will actually help companies like Mysten or others to actually bring Web3 to like everybody?
Yeah, so I think you can see like in the Web3 space, there's a lot of bad actors and a lot of bad behavior. And I think a lot of that, I mean, people are going to do bad things regardless, but I think a lot of that comes from lack of regulatory guidance and crackdown that disincentivize people from doing that. Like you look at the blow up of Terra, like this is very bad and the thing that had consumer harm and a thing that really poisons the well for others in the space. So I think taking a more active role in regulation to help both to help foster innovation in the space, but also just to like crack down on some of the really bad stuff that is giving Web3 the bad reputation that it has in some circles along some folk and in some communities is going to be super, super critical. And like, I think one thing that, we're particularly interested in, or at least we're very curious to see how it shakes out, is that there are many regulations around fungible tokens, like NFTs is a big open question. And for us and for a lot of customers building on us and just folks in the space in general, like knowing, are you in the future, will you need to be a custodian to hold NFTs for your customers? Will this be treated differently? Like, are all NFTs commodities or securities? Are there some subset that aren't? And like, what are the distinguishing factors for these? I think just getting clarity on those really helps folks know how they should be building and what they can do to keep their customers safe and to make sure their business is targeting the right problems. So this is sort of a non-answer and more sort of like surveying the space. But I think like if Web3, if people always say with Web3, it's early and we have a long way to go, even more so for Web3 related regulation.
Awesome. That's a great ending. So we want to actually thank you a lot, Sam, for actually come to the Stanford Blockchain Club to actually give us a fireside chat regarding Mysten Lab, regarding all the lessons you learned from Meta, and then we wish you best of luck to actually for the next chapter of Mysten Lab.
Absolutely, it was my pleasure. Thank you so much for hosting me and for your great questions. Really appreciate all y'all.
Thank you, Sam.
All right, have a good evening.
Thank you. Bye-bye.